400 amp 250 volt 3-phase service entrance rated panel was installed with two 150 amp 3-pole breakers, one 100 amp 3-pole breaker, and one 100 amp 2-pole breaker. Non-reversing screws are installed in unused bus space. The local inspector stated that the panel is not legal. According to the National Electrical Code, the panel might not be legal for a few reasons. Firstly, the non-reversing screws. Non-reversing screws must be installed in all unused bus spaces to prevent breakers from being moved into those spaces. If the panel only has non-reversing screws in the main breaker section, then this is a violation. Secondly, the breaker capacity. The National Electrical Code requires that main circuit breakers not exceed 80% of the panel's ampacity. If the panel is rated for 400 amps, a breaker in the main section exceeding 80% of 400 amps violates this requirement. To determine what to do since the panel is already installed, a few options exist. 1. Replace the main breaker. Replace the 150 amp main breaker with a breaker rated for a smaller amperage to reduce the main breaker capacity to below 80% of the panel's ampacity and meet the National Electrical Code requirement. A 100 amp breaker would solve this issue. 2. Add non-reversing screws. Install non-reversing screws in all unused bus spaces, both in the main breaker section and the branch breaker section. This prevents breakers from being moved into those spaces and ensures safety. 3. Install a new panel. If the above options are not feasible or acceptable, install a new panel that meets the National Electrical Code requirements. This may involve removing the existing panel and installing a new one, or it may require modifying the existing panel. Furthermore, consider local codes and warranty. Check with the local building department to verify if there are any additional requirements or restrictions that may apply to the panel. The manufacturer of the panel may not honor the warranty if the panel is not installed in accordance with the National Electrical Code. It is important to ensure that the electrical panel is installed safely and meets all applicable codes to prevent electrical hazards. It is recommended to consult with a qualified electrician to determine the best course of action to resolve this issue. In general, electrical panels are designed to distribute electrical power safely and efficiently throughout a building. They contain circuit breakers or fuses that protect individual circuits from overloads and short circuits. A service entrance panel is the main electrical panel in a building where the electrical service from the utility company enters. The National Electrical Code, or NEC, is a widely adopted standard for safe electrical installations in the United States. It provides comprehensive guidelines for electrical wiring, equipment, and systems. The NEC is updated every 3 years to reflect changes in technology and best practices. A non-reversing screw is a type of screw that can only be installed in one direction. This prevents breakers from being moved into unused bus spaces, which could create a safety hazard. Bus bars are conductive strips or bars inside an electrical panel that distributes electrical power to the circuit breakers. Ampacity refers to the current carrying capacity of a conductor or electrical equipment, expressed in amps. It is the maximum amount of current that a conductor can safely carry without exceeding its temperature rating. A circuit breaker is an automatic switch that protects an electrical circuit from overloads and short circuits. It interrupts the flow of current when a fault is detected, preventing damage to equipment and reducing the risk of fire. A three-phase electrical system is a type of alternating current system that uses 3 conductors to deliver power. It is commonly used in commercial and industrial applications due to its efficiency and ability to handle large loads. A 2-pole breaker is a type of circuit breaker that protects 2 circuits simultaneously. It is commonly used for appliances that require 240 volts, such as electric dryers and water heaters. Consulting with a qualified electrician is crucial for ensuring the safety and code compliance of any electrical installation or modification. Electricians have the knowledge and experience to properly assess the situation, identify potential hazards, and recommend the appropriate solutions. When evaluating the legality of an electrical panel installation, several factors must be considered. Firstly, compliance with the National Electrical Code, or NEC, is paramount. The NEC sets the standard for safe electrical installations, and local jurisdictions often adopt it as the basis for their electrical codes. Secondly, local codes and regulations may impose additional requirements beyond those specified in the NEC. It is essential to consult with the local building department to ensure compliance with all applicable codes. Thirdly, the panel's listing and labeling must be verified. Electrical panels are typically listed by independent testing laboratories, such as Underwriters Laboratories or ETL-SEMCAR, to ensure that they meet safety standards. The panel's label should indicate its voltage and amperage ratings, as well as other important information. Fourthly, the panel's installation must comply with the manufacturer's instructions. Manufacturers provide detailed instructions for installing their products, and these instructions must be followed carefully to ensure safe and reliable operation. Fifthly, the panel's grounding and bonding must be properly implemented. Grounding and bonding are essential for protecting against electrical shock and preventing equipment damage. The NEC specifies detailed requirements for grounding and bonding electrical systems. When addressing the specific issues raised in the question, several points should be clarified. Firstly, the statement that the panel is rated for 400 amps should be verified. The panel's label should clearly indicate its amperage rating. Secondly, the size and type of the main breaker should be confirmed. The main breaker protects the entire panel from overloads, and its size must be appropriate for the panel's ampacity. Thirdly, the number and size of the branch circuit breaker should be determined. Branch circuit breakers protect individual circuits within the panel, and their size must be appropriate for the loads they serve. Fourthly, the presence and location of non-reversing screws should be verified. Non-reversing screws prevent breakers from being moved into unused bus spaces, which could create a safety hazard. If the panel is found to be non-compliant with the NEC or local codes, corrective action must be taken. This may involve replacing the main breaker, adding non-reversing screws, or installing a new panel. It is important to consult with a qualified electrician to determine the best course of action. In addition to the specific issues raised in the question, several other factors should be considered when evaluating the legality of an electrical panel installation. Firstly, the panel's location must comply with code requirements. Electrical panels must be located in accessible locations and must not be installed in hazardous locations such as bathrooms or damp areas. Secondly, the panel's wiring must be properly sized and installed. The NEC specifies minimum wire sizes for different types of circuits, and these requirements must be followed to prevent overheating and fire hazards. Thirdly, the panel's overcurrent protection devices must be properly selected and installed. Overcurrent protection devices, such as circuit breakers and fuses, protect circuits from overloads and short circuits. These devices must be properly sized and installed to ensure that they will operate correctly. Fourthly, the panel's grounding and bonding system must be properly installed and maintained. Grounding and bonding provide a path for fault current to flow back to the source, which helps to protect against electrical shock and prevent equipment damage. Fifthly, the panel must be properly labeled. Labels should be used to identify the circuits served by each breaker, as well as other important information. Failure to comply with these requirements can result in electrical hazards, equipment damage, and code violations. It is essential to consult with a qualified electrician to ensure that all electrical work is performed safely and in accordance with applicable codes. Let's delve deeper into the technical aspects of electrical panel installations and the National Electrical Code requirements. The NEC, published by the National Fire Protection Association, is a comprehensive set of standards that govern the safe installation of electrical wiring and equipment in the United States. It is updated every 3 years to reflect changes in technology and best practices. The NEC is not law itself, but it is widely adopted by state and local jurisdictions as the basis for their electrical codes. Article 110 of the NEC covers general requirements for electrical installations, including requirements for workmanship, equipment listing and labeling, and conductor ampacity. Article 220 covers branch circuit, feeder, and service calculations, which are used to determine the appropriate size of conductors and overcurrent protection devices. Article 230 covers services, which are the conductors and equipment that deliver electrical power from the utility company to the building. Article 240 covers overcurrent protection, which includes circuit breakers and fuses. Article 250 covers grounding and bonding, which are essential for protecting against electrical shock and preventing equipment damage. Article 310 covers conductors for general wiring, including requirements for installation, ampacity, and installation methods. When evaluating the legality of an electrical panel installation, it is important to consult the relevant articles of the NEC to ensure compliance with all applicable requirements. One of the key concepts in electrical panel installations is ampacity, which refers to the current carrying capacity of a conductor or electrical equipment. The ampacity of a conductor is determined by its size, insulation type, and ambient temperature. The NEC provides tables that list the ampacities of various types of conductors. It is important to select conductors with sufficient ampacity to carry the expected load. Another important concept is overcurrent protection, which is provided by circuit breakers and fuses. Overcurrent protection devices are designed to protect circuits from overloads and short circuits. When an overcurrent occurs, the overcurrent protection device will trip or blow, interrupting the flow of current and preventing damage to equipment. The NEC specifies the maximum allowable overcurrent protection for various types of circuits. Grounding and bonding are essential for protecting against electrical shock and preventing equipment damage. Grounding provides a path for fault current to flow back to the source, which helps to trip the overcurrent protection device and energize the circuit. Bonding connects all metal parts of the electrical system together, which helps to equalize the voltage and reduce the risk of electrical shock. The NEC specifies detailed requirements for grounding and bonding electrical systems. In the specific case of the 400 amp 250 volt 3-phase service entrance rated panel, several issues need to be addressed. Firstly, the size of the main breaker should be verified. The NEC requires that the main breaker not exceed the ampacity of the service entrance conductors. If the 150 amp main breaker exceeds the ampacity of the service entrance conductors, it must be replaced with a smaller breaker. Secondly, the presence and location of non-reversing screws should be verified. Non-reversing screws are required in all unused bus spaces to prevent breakers from being moved into those spaces. If the panel only has non-reversing screws in the main breaker section, additional non-reversing screws must be installed in the branch breaker section. Thirdly, the size and type of the branch circuit breaker should be verified. The NEC specifies the maximum allowable overcurrent protection for various types of circuits. If any of the branch circuit breakers are oversized, they must be replaced with smaller breakers. Fourthly, the grounding and bonding system should be inspected to ensure that it is properly installed and maintained. The grounding electrode conductor should be properly sized and connected to a grounding electrode, such as a ground rod or water pipe. All metal parts of the electrical system should be bonded together with bonding jumpers. By addressing these issues, the electrical panel installation can be brought into compliance with the NEC and local codes, ensuring the safety of the building occupants and protecting against electrical hazards. In addition to the above considerations, it is also important to ensure that the electrical panel is properly labeled. The NEC requires that all circuits be clearly identified with labels indicating the loads they serve. This helps to prevent confusion and makes it easier to troubleshoot electrical problems. The labels should be durable and easy to read. They should be attached to the panel door or adjacent to the circuit breakers. It is also important to keep the electrical panel clean and free of obstructions. Dust, dirt, and debris can accumulate inside the panel and cause overheating or other problems. The panel should be inspected regularly and cleaned as needed. The area around the panel should be kept clear of obstructions to allow for easy access and ventilation. Finally, it is important to remember that electrical work can be dangerous. It is always best to consult with a qualified electrician before attempting any electrical repairs or modifications. Electricians have the knowledge and experience to perform electrical work safely and in accordance with applicable codes. Attempting to perform electrical work without proper training can result in electrical shock, fire, or other hazards. By following these guidelines, you can help to ensure the safety and reliability of your electrical system. Remember to consult with a qualified electrician if you have any questions or concerns about your electrical system. Let's explore some specific scenarios related to electrical panel installations and NEC compliance. Suppose a homeowner wants to add a new circuit to their electrical panel. Before doing so, they should first determine the load that the new circuit will serve. This includes the wattage of all appliances and equipment that will be connected to the circuit. Once the load is known, the homeowner can calculate the required circuit amperage. The NEC provides tables that list the ampacities of various types of conductors. The homeowner should select conductors with sufficient ampacity to carry the expected load. The homeowner should also select an appropriate overcurrent protection device, such as a circuit breaker or fuse. The NEC specifies the maximum allowable overcurrent protection for various types of circuits. The overcurrent protection device should be sized to protect the conductors from overloads and short circuits. The homeowner should then install the new circuit wiring in accordance with the NEC and local codes. This includes properly securing the wiring, using approved wiring methods, and making proper connections. The homeowner should also properly ground and bond the new circuit. Once the new circuit is installed, the homeowner should test it to ensure that it is working properly. This includes checking the voltage, amperage, and polarity of the circuit. The homeowner should also label the new circuit breaker with a description of the loads it serves. Another common scenario involves replacing an existing electrical panel. When replacing an electrical panel, it is important to select a panel that is properly sized for the building's electrical load. The NEC provides guidelines for calculating the building's electrical load. The new panel should have sufficient capacity to handle the existing load, as well as any future load additions. The new panel should also be listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories or ETL Semco. The new panel should be installed in accordance with the manufacturer's instructions and the NEC. This includes properly grounding and bonding the panel, connecting the service entrance conductors, and installing the branch circuit breakers. The old panel should be disconnected from the power source before being removed. The service entrance conductors should be properly terminated in the new panel. The branch circuit conductors should be properly connected to the new circuit breakers. The new panel should be labeled with a description of the circuits it serves. After the new panel is installed, it should be inspected by a qualified electrician or electrical inspector to ensure that it is in compliance with the NEC and local codes. In addition to these scenarios, there are many other situations that may require modifications or repairs to an electrical panel. These include adding new circuits, replacing damaged breakers, and upgrading the service entrance. It is important to consult with a qualified electrician before attempting any electrical work. Electricians have the knowledge and experience to perform electrical work safely and in accordance with applicable codes. Remember that electrical work can be dangerous. It is always best to err on the side of caution and seek professional assistance when needed.